the chemical kinetics or speed of a chemical reaction. Speed of a chemical reaction means how much time the reactant will take to form a product. That's refers to chemical kinetics. So the definition, the rate of a reaction or a speed of a chemical reaction is a change in concentration of a substance, because this substance can be changed in concentration for reactant or it can be product. So how much time the reactant will take to form a product, or time taken by or change in concentration of a reactant with respect to time, or the change in concentration of a product with respect to time. Amount of reactant will decrease and amount of product will increase. In the beginning, because the reaction will start up at a faster rate, because you will have more particles. So greater the number of the particles, greater the speed of the chemical reaction, because more effective collagen. But with the passage of a time, the rate decreases. Why the rate decreases? Because you will have few particles or less particles available for a collagen. So if we define the speed of a reaction is refers to how much change in concentration of a substance with respect to time. This substance can be reactant, this substance can be product. The reactant amount will decrease and the product amount will increase. So if we sketch a graph for reactant, so in the beginning, we have more reactant. With the passage of the time, reactant decreases. Eventually, the reaction stops. So then we'll have a horizontal line. And what slope represent? The slope represent the rate or the speed of this reaction. Steeper slope, it means faster rate. Slope decreases, it means the rate is also decreasing. And here at this point, the slope is 0. It shows that the rate is also 0. So if in the graph you have the concentration of a reactant, it will start with a maximum value. With the passage of a time, concentration of a reactant decreases. Eventually, there is no change in concentration, which shows that the reaction stops. But if the same graph is there for a product, concentration of a product, so then if it was a graph for concentration of a product, in the beginning, you will have 0 product. With the passage of a time, amount of product increases, and eventually there is no change in amount of product. This shows that the reaction stopped. And again, the slope or the gradient represent the rate or the speed of the chemical reaction. If I need speed of a chemical reaction at any point, what I will do, I will draw a tangent. So if I need initial rate, I will draw tangent at the beginning. If I want to find a rate at a specific time interval, like example, if it was 3, so I'll mark a point where time is equals to 3, and I will draw the tangent. If I need at time is equals to 4, so I will draw a tangent when time is equals to 4. In the beginning, why faster rate or steeper slope of a tangent? Because you have more reactant particles. Greater the amount of particles of reactant, they have more effective collagen. This leads in a faster formation of the product. Is it clear? This concept of speed or rate of the reaction. So you can find the speed or the rate of a reaction by finding a gradient or the slope. If you need initial rate, you will draw a tangent at the beginning. But if you need a rate at a certain time interval, so according to that time interval, you will draw a tangent. Any doubt in this? Students, those who joined or started now, for them, because This is unit 4, first topic, chemical kinetics. And I will share the slides with the presentation with you so you can copy from the presentation. The last session, normally I'll conduct 3 sessions, Zoom meetings. So the last session I will discuss the past papers for students already finished the course. But those who joined late, they have option for that. If they want to attend, that's okay. Otherwise, they can attend only 2 sessions. How we can investigate or measure the speed or the rate of the reaction. So there are different ways to investigate the speed or the rate of the reaction. Number one, you can measure the change in volume of a gas. For this technique to use, the product should be there should be a gaseous product. You can see here, it's trichloromethane is there. Sorry, not trichloromethane. It's CH3 group is there. So it is 2,2-dimethyl. So when we select the longest chain, this will be the IUPAC name CH3, CH3, CH3. So we select the longest carbon chain. This is 1, 2. So 1-chloro, 2,2-dimethyl, and ethane is there. That's a chemical name of this. So for this reaction to occur, the condition is that there should be a gaseous product. The gas should be there as a product. So when the gas released during a chemical reaction, what will happen? This gas will push the plunger of this gas syringe, so we can record the volume of the gas. Another apparatus which is required to measure the speed or the rate of a reaction, because we need a time, we record the change in concentration with respect to time. So for time, we should have a stopwatch. If any acid is reacting with metal, like example, if there was magnesium reacting with hydrochloric acid, so magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. So you can see hydrogen, a gas is given off. So whenever there is a gas given off, we can use this technique. So we need a gas syringe, or we can use a measuring cylinder as well, inverted on the water, so that we can observe if any insoluble gas is given off. So this only works when there is a change in concentration or amount of moles of a gas. Is it clear? This is a technique which can be used to measure the speed of, this is one of the technique which can be used to measure the rate or the speed of reaction. So if you want to measure the rate or speed of reaction, so we will have volume of the gas and the time. Volume of gas example, it's centimeter cube, and time is there in second. The formula to calculate the rate is change in concentration of either reactant or product divided by time interval. So you're measuring a volume every 2-second time interval. In the beginning, because it's a product, so in the beginning you will, at the start of a reaction, there is no gas given off. Once a reaction started, the gas is released. Example, it was 30. Then after 4 seconds, it was 50 or 4 minutes. Then it is 55. Then it is 57. And it is 57. So when I calculate the rate here in first 2 seconds, so the change in concentration or change in amount or change in volume is 30 and the time interval is 2. So 30 divided by 2, which is equals to 15. And the unit of this rate, because the volume of a gas divided by time, so it will be centimeter cube per second. So it was, then it is 30 changed to 50. So the change is 20. So this will be 20 divided by 2. We'll get 10. Then it's 50 become 55. So it is 5 divided by 2, which is 2.5. Then it is 55 changed to 57. So 2 divided by 2, that's equal to 1. The change is 2 and the time interval is also 2. That's why it's 1. And 57, so there's no change. So this is 0 divided by 2. That's why the initial rate is, the final rate is 0, which shows that the reaction stopped, or one of the reactant, which one is the limiting, used up, or maybe if both of the reactants are in same quantity and same mole ratio, then both of them are used up. Is it clear? This is the first method to measure, investigate, or measure the speed of reaction or rate of reaction by measuring the volume of the gas. Any doubt in this? The second technique which can be used to measure the speed of the reaction or uh, rate of the reaction, we can measure the change in mass. For this method to be useful, it will work when the gas is given off, and the gas which is given off should be a heavy gas. If it's a lighter gas, such example hydrogen is there, the mass will change, but negligible change in mass will occur. So heavy gases such as carbon dioxide is there. So this will be more effective. How we carry out this method experimentally? So what we will do, we'll take a conical flask. So we have a conical flask, and this inside this conical flask we have a reaction mixture. And this conical flask is placed on the balance. And there's a reaction mixture. So we measure the mass initially, and then we add a substance. So both will react. As a result of this reaction, it is giving out a gas. To avoid any loss of content, so we place a cotton at the mouth of this conical flask. The purpose of this cotton is not like to allow the gas to escape. The idea is that so content of the flask will not escape. Maybe a violent reaction is there. So maybe there is some splashing may occur in the liquid. So that, or a solid might decomposing during a chemical reaction. So there might be a loss in the mass of a solid. To overcome this, or loss in mass of the liquid, to overcome this, we place a cotton so that the air can, or the gas can escape, which is produced, and the content of the flask, the reaction mixture, is not lost. So what we'll observe the mass in the beginning, it is higher, but with the passage of the time, the mass will increase. If we sketch a graph for the results for this reaction, in the beginning, we have a greater mass in the flask, but with passage of a time, the mass decreases. Eventually, it will be constant. It will not reach zero. Why the mass will not reach zero? Because still there is a mass of a conical flask. Even if you consider all of the reaction mixture converted into a gaseous product, still there will be a mass, and that mass is the mass of the flask. So practically its mass, it does not touch the x-axis. If it touches the x-axis, it means the mass is 0, but practically it cannot be 0. And if we want to find the rate or the speed of the reaction, so what we can do, we can draw a tangent. And if we need initial rate, the rate speed in the beginning, so we'll draw a tangent at this part. If we need a rate at a specific time interval given in the question, so we'll draw a tangent at that specific point. So here, methanoic acid is reacting with bromine. So it is giving carbon dioxide gas. So carbon dioxide gas is there. So as it escapes, the mass will decrease. Is it clear? The second technique to measure speed or the rate of the reaction. Then third technique, which can be used to measure the speed of a reaction, is a titration. So what we will do, we can use a concept of a titration to identify the speed or the rate of reaction. And this technique works best if there is an acid is there in the reaction mixture, or alkali is there in a reaction mixture, or sodium thiosulfate is there, or iodine is there. Because titration is practically, we are doing a titration of acid base, and there is also a redox titration of iodine and thiosulfate. So any substance, if it contain, like any reaction mixture, if it contain acid, alkali, or sodium thiosulfate or iodine, we use this technique to find the rate or speed of reaction. How this technique works? So example, if I say there is a flask or a beaker is there, example, and a beaker is filled with hydrochloric acid. See, a hydrochloric acid was reacting with less reactive metal, example iron, relatively less reactive. So if iron, and it forms iron 2 chloride and hydrogen gas is there. I can also measure this reaction by, like, if one reaction can be measured or speed can be measured by different or multiple ways, because you can see here the gas is given off, so I can measure the volume of the gas to measure the speed of a reaction. Or this gas is a lighter gas, but still I can use change in mass of content, and I can measure the rate of reaction. Or I can also use titration method. How we use this technique, example, in a flask or a container, iron was reacting with hydrochloric acid. So what we will do, we will take out the sample, a small amount of sample, not too much. We take out a small amount of sample and we transfer that into a conical flask. But the problem with this method, it should be done quickly. Otherwise, what happens? The results will not be accurate. So what happens when you take out the sample? In this sample, there is iron also and hydrochloric acid, and still the reaction is going on. So first thing, what you want to do, you have to quench, or you have to stop the reaction. So how you can stop the reaction? Quenching can be done in different ways. Like if I want to stop reaction, some of the reactions can be stopped by changing the temperature or lowering the temperature. Some of the reactions can be quenched by adding another substance which does not allow them or makes substance to react. So different ways are there to quench. So even by adding a chemical, also quenching can be done, or by changing the physical conditions like temperature, pressure, quenching can also be done. So what we will do first, So first we'll quench, and after quenching, so quenching means the sample we took out from the flask, the beaker, so that the concentration or amount of hydrochloric acid will not change. That's why first we quench. So we can quench by different ways, either adding a reagent or changing the condition. Then we will titrate this. We will titrate with alkali, a known alkali of a known concentration. So we will titrate. So example, we had sodium hydroxide, NaOH. So HCl reacted with sodium, and we took a small quantity, so we don't need too much sodium hydroxide, very small quantity. Maybe example, in the beginning, you need 5 cm cube of sodium hydroxide in the beginning. When time, and you take out the sample, this is just at the beginning of experiment, so means that time is equals to 0. And sodium hydroxide was 5 cm. Then what we'll do after another 30 seconds, or after, normally 30 seconds is not practically possible to do all this thing. So example, after 2 minutes, we take out another sample, sample 2, and again we titrated with sodium hydroxide, and we observed the amount of hydrochloric acid which was required is 3 cm cube. Then further, after further 2 minutes, another 2 minutes, we take out the sample 3 and again we titrated, and the amount of sodium hydroxide required was example 2 cm cube. Then after 6 minutes, we take out another sample and we titrated, and we observed that the amount of sodium hydroxide required is 2 cm cube. So what it shows that the reaction used, if amount, because why in the beginning we need greater amount of sodium hydroxide, because HCl was a reactant. So in the beginning you have greater amount of reactant, that's why you need greater amount of sodium hydroxide for titration or neutralization. But as you take out another sample 2, after 2 minutes, as the hydrochloric acid is a reactant, so amount of hydrochloric acid in the sample will be less. That's why only 3 cm cube is required after 2 minutes. Then after another 2 minutes, means after 4 minutes interval, compared to the starting of experiment, you need 2 cm cube of hydrochloric acid. The amount of hydrochloric acid, you need 2 cm cube of sodium hydroxide, and then at the last you need the same amount. So what it shows that the reaction stopped, the amount of hydrochloric acid is not changing. So by amount of change in concentration divided by time, we can also identify the speed or the rate of this chemical reaction. Is it clear, this concept? So this can be done if we are having iodine, and if any chemical reaction involves formation of iodine or formation of thiosulfate. If a reaction involves any acid or alkali, we can use this technique. Is it clear, this concept? So titrating sample of a reaction mixture with acid, alkali, sodium thiosulfate, or so this in, we can see in this reaction, methyl methanoate was hydrolyzed by sodium hydroxide, so sodium methanoate is there, and ethanol. So you can see we have sodium hydroxide, so we can use a titration, and this sodium hydroxide can be titrated with acid. This is a bromate 5 ion. This is just ionic equation, not a complete equation. It can be sodium bromate 5 reacted with bromide ion in the presence of acid. From where? Because H plus is there, so it is coming from acid. So this H plus of an acid can be neutralized by an alkali. Or iodine reacted with, this one is propanol. It's a ketone. Propanol react with iodine, so it will form hydropropanol. plus hydrogen ion plus iodide ion. So this iodine molecule can be titrated with thiosulfate using a iodine thiosulfate titration. Is it clear? This concept of measuring a speed or the rate of reaction by using a technique, titrations. So we take out the sample and quench, and then we use a suitable reagent for the reaction to occur. Any doubt in this? Colorimetry can also be used. It's from the term color. So because what happened, some of the reactant, when they form a product, maybe a product is a colored substance. So if one of the reactant or product is a color, we can also use to measure the change in the color in the reaction mixture. So what happened, like example, hydrogen peroxide reacted with iodide ion and acidic medium. So we can use it form a water and iodine molecule, and aqueous iodine is brown. If it is dilute, then it will be yellow. Otherwise, it is brown. Iodine is having different colors in different medium. If it is in acid, if it is aqueous, then it can be yellow or brown. If it is in organic solvent, then it can be pink or purple. Iodine itself, as a solid, it is black or purple, but depending on dissolve, if it is, because it is having weak van der Waals force, so it is soluble in both aqueous and it is soluble in both water and alcoholic or organic liquids, and shows a different color. So you can see a colored substance is there, so we can observe or use a colorimetry to identify how it is done. It's basically you will have a sample, a flask, a container with a reaction mixture, and you have a source of the light. With the passage of a time, and you can have a photo sensor here or a light sensor or a photo cell, and then this photo cell is connected to a meter. Ammeter, you can have an ammeter which shows up. So as the sample will, originally it is colorless, but with the passage of a time it will turn brown because of iodine. So as it turned brown, the amount of the light, which in the beginning more light is passing, but as iodine amount increases, the solution turned brown. So the color of, like, you can measure the color with respect, you can measure the current which is produced by the cell with respect to time. So in the beginning, say example, it was 2 milliampere, but as the reaction started after 2 seconds, it was 1.8 milliampere or 1.5. After 4 seconds, example, it is 1 milliampere. So what it shows, as the current is decreasing, it means that the color intensity is increasing, so less amount of light can pass through. Most of the light is absorbed. There is also another technique which can be used, as I just discussed now with you, that because if iodine is there, so you can use a titration technique. Hydrogen ion is there also, or acid is there, you can also use titration method. But you cannot use the change in mass or change in volume. Reason for that, it does not involve any gaseous reactant or a product. Measuring the change in electrical conductivity. So what we can do, we can use the concept of electrolysis, like a reaction mixture. Sorry. A reaction mixture, and you can have two electrodes. Then a source of energy, a power supply with an ammeter. This is only possible if there is a change in ions. If ions change, if molecular number change, like if number of molecules change, it will not make difference there should be a change in the ions or aqueous substance. So in the beginning, you can see methanoic acid is there, yeah, bromine and so there in the beginning there are no ions, all molecules. This is like there is in methanoic acid, hydrogen ion and but it's a weak acid. Weak acid does not ionize completely, so few ions are there. But as the reaction occur, hydrogen 2 hydrogen ion, bromide ion, so number of the ions changes or increases, so conduction will also change. And the last technique which you can use is optical activity. Optical activity, those who studied already the concept of polarization can understand this. The term polarization means that the light which is having only one component, that's called a polarized light. The light which is having multiple components, that's called unpolarized light. So normally the source of the light which we are using, all these sources are unpolarized light except the laser one. But we are not using laser in everyday life. So most of the light which is emitted out from the source is polarized, unpolarized light. So using a polarizer or polarizing filters, when we pass this light through a polarizing filters, these polarizing filters, if the light which is passing, the component which is parallel to the plane of the polarizing filter is regenerated or able to pass through, but the components, other components which are not parallel to polarizing filter plane, they are not able to pass through, and then this light is known as polarized light. So we can also measure the rate or speed of a reaction by observing the optical activity. What is the concept of optical activity? Like you will have a container. Now you have the polarized light, and this polarized light you are passing through a container. When you pass this polarized light through a container in the reaction mixture in the beginning, so some of the reactant molecules have a tendency to rotate the polarized light. Example, in this case, it is rotating the light clockwise. They absorb and they rotate the light clockwise. You can see this is a clockwise rotation compared to original plane. But what happened as the reaction occurs? So in the beginning, the light is rotated by the reactant molecules clockwise. But as the reaction occurs and it leads in the formation of a product may also have optically active enantiomers or molecules. So these molecules, what they can do, they can change the polarized light plane. So as the reactant is changing into product, so what we will observe, we'll observe the plane of the polarized light is also changing. So in the beginning, it was rotating, say clockwise, but as the product is formed, then the same light is rotated anti-clockwise. So this give an indication to how much time the light will take to change its plane. So we can identify the speed or the rate of the reaction. This is only valid if there are optically active, either optically active reactant or a product. Optically active reactant product, about this in the last chapter, last topic in discussion of chiral carbon, we'll discuss how the molecule can be optically active. These are different ways to measure the speed or the rate of the chemical reaction. Practical ways to measure rate or speed of chemical reaction. Is it clear? Any doubt in this? Then rate equation, as we know, the rate of a reaction is directly proportional to concentration of the reactants. That's a rate law, that rate of a reaction proportional to concentration of the reactants. So example, a reaction is there in which A is reacting with B and it's forming a product C. So if you want to write a rate, there is rate expression and rate equation. Equation involve a constant, expression because it says rate is proportional to concentration of the reactant. To represent the concentration, we use the square bracket. So example, in this reaction, we have A and B are the reactant. So that's why if I write a rate expression, so in rate expression, I'll say rate is equals to or proportional to concentration of A and concentration of B. And the coefficients of the reactant, like here coefficient is A and B, that will turn into power. Like this will be A raised to power small a and B raised to power small b. This is called a rate expression because I did not use equal to. Now, whenever we replace in a mathematics, whenever we replace a proportionality sign, we replace with equal to and constant. So I can say rate is equals to constant times concentration of A and concentration of B. So this is called a rate equation where the sum of these powers or exponent of the concentration of reactant is known as the order of reaction. So what is the order of reaction? Here A having a raised to power small a and B raised to power small b. So what is the order of this reaction? So order of this reaction will be A plus B. Or in this example, they took actually it should, instead of A, it should be written M and this is written N. So A raised to power M and B raised to power N. So if I say what is the order of this reaction? So order of this reaction is M plus N, the sum of the exponents of concentration of the reactant. Then reactant can be first order, it can be second order, or it can be third order or zero order as well. But you will learn only discuss only three types: zero order reaction, first order reaction, and second order reaction. So when we write the expression, like we use a proportionality sign, but when we write equation, we use equal to sign and we replace with constant. Here K is a constant, that is also known as rate constant. This rate constant having different units, it depends on the question, it depends on the equation which is given to you. Any doubt in this rate equation? Less than a minute left, so I'll share another link.